Welcome to today's lesson. Today we're going to look at taking readings on the Vernier Calipers. This is a very important lesson because to enable us to actually be able to read or to take readings as we measure the width or the internal diameter of an object as well as the external diameter of the object. And so here we go now, starting the lesson. So the Vernier Calipers has these parts. It has the main jaws. These jaws, this part number 2, the jaws are used to measure the internal diameter of an object, while the jaws labeled 1 are used to measure the external diameter of an object. The Vernier Calipers has 2 scales, the Vernier scale and the main scale. It has also the depth probe. So the Vernier scale actually has the 0.9 centimeter scale, which is divided into 10 equal parts. In other words, what we mean is that this Vernier scale is divided into 10 equal parts. The main scale is graduated in centimeters and millimeters, meaning that it is measured in centimeters as well as millimeters. So the parts on the Vernier scale, as I indicated earlier, it has the outside jaws, which are used to measure the external diameter. Also the inside jaws, which are used to measure the internal length or internal diameter of an object, as I indicated earlier on. So when you are using the Vernier calipers, first of all, you have to find the least count. The least count on the Vernier calipers is found by, first of all, getting the main scale smallest division. On the main scale, you get the smallest division. And this is 1 millimeter. And then you get the total number of Vernier scale divisions. And we said there were 10. So I'm going to divide 1 divided by 10, which gives you 0.1 millimeter. So what do you do when you want to make a reading on the Vernier calipers? The first thing you have to do is to take note of the zero error. At times, the Vernier scale would not coincide appropriately with the main scale. That is before taking the reading. Because the zero mark on the main scale is supposed to be on the same line with the zero mark on the Vernier scale. So if these are not in line when you close the contacts of the Vernier calipers, it means that there is an error. So you have to take note of that error. And then you calculate the least count, the way we did it. And then place the object between the jaws. And then you take the reading on the Vernier scale. And then lastly, you take the reading on the Vernier scale. After taking the reading on the main scale, you take the reading on the Vernier scale. That is where actually they coincide. The strokes actually coincide with the main scale. So the scale would be, the reading would be actually equal to the main scale division plus the coinciding Vernier scale reading multiplied by the least count. So now we are going to have this general question we are going to look at so that it enables us to understand exactly what we are talking about. So here's a simple question. What is the reading on the Vernier Calipers? So we are given that this is the main scale and it is in millimeters. And from here you can see that it is actually in millimeters. And then the Vernier scale also is written down here. So the first thing we have to do is that we get the reading from the main scale. And how do you get the reading? You check where the Vernier scale starts. So this is the 0 mark where the Vernier scale starts. So the reading will be taken to the left of the 0 mark from only the Vernier scale. So this is the point we are going to concentrate. We are going to take as a reading on the main scale. If this is 5, this is 6, 7, 8, 9, 10. So this will be 4, this will be 3, and this will be 2. So our reading here would be 2 millimeters. So you take the main scale reading is equal to 2 millimeters. Now we take the Vernier scale reading. How do you get the Vernier scale reading? You check on these strokes which are here. You check where they are coinciding. By coinciding means they are in the same line. So if you check starting from this one, this one, this one, you notice that the one which is number 5. This is 1, 0, 1, 2, 3, 4, 5 is the one coinciding with the one on the main scale. So you take this one as Vernier scale reading is equal to 5. And therefore our reading would be equal to main scale reading plus Vernier scale reading multiplied by the least count. And as we saw there, the least count is 0.1 millimeter. And therefore, we say 2 millimeter, which we got, plus 5 readings we got from the Vernier scale multiplied by 0.1. So this gives us 2.5 millimeters. Okay, another question. You note that the previous question that we looked at, we didn't consider any error. We said there was no error. But these ones now, the few questions we are going to discuss, they are errors. And therefore, in each reading, we are going to take into account the errors. So the jaws of a Vernier calipers are in contact. Calculate the zero error of the Vernier calipers. So we have here the main scale division, which is 1 millimeter. And on the Vernier scale, they are saying 10 Vernier scale divisions is equal to 9 main scale divisions. Okay, and you notice that here, they are not in the same line. Ideally, when they are in contact, before you put an object, the zero error on the main scale, this zero error on the main scale, zero error on the main scale is supposed to be in line with the zero mark on the Vernier scale. But you notice that these are not. So this one has gone ahead here. And so what you do, first of all, you get the least count. The least count, we are going to say this main scale division, which we got as 1 millimeter, minus Vernier scale division, which you got as they are 9 out of 10. So it means that it will be 9 divided by 10. So we're going to say 1 minus 9 divided by 10, which gives us 0.1 millimeters. So we take the reading now on the main scale reading. On the main scale reading, we know that it has not even reached where this 0 mark is. it has not reached. So the nearest here to the 0 mark, because that's how you read. You check on the nearest to the 0 mark of the vernier. So the one which is nearest to the 0 mark of the vernier is actually 0 on the main scale. So we are going to write main scale reading is equal to 0. Then we look at the vernier scale reading. We look at where the strokes are coinciding or they are in the same line. So you notice that this is 0, 1, 2, it's on number 3. So our vernier scale reading would be 3. And therefore our 0 error would be equal to main scale reading plus vernier scale reading multiplied by the least count. And our main scale reading, we found 0 plus the 3 as the vernier scale reading multiplied by the least count, which is 0.1, which gives us 0.3 millimeters as our 0 error. Another question, the vernier calipers in question 1 was used to measure the size of the external diameter of the cup, calculate the diameter of the cup. So this same scale with an error of 0.3 millimeters, we used this same vernier calipers to measure the diameter of the cup. So in this case, we're going to take into account the error as well as the least count. So what we do here is our question. After we have actually put the cup in the jaws, this is what we find. So we have to take the reading on the main scale. And we said, how do we take the reading on the main scale? You check on the vernier scale. So the 0 is just before what? On the left. So if this is actually, these are millimeters. So this is 21, 22, 23, 24, 25. So it's 25 just before the 0 mark on the vernier scale. So you write the reading. Main scale reading is equal to 25 millimeters. Then we get the vernier scale reading. The vernier scale reading, you look at where the strokes for the vernier scale are coinciding with the strokes on the main scale, where they are in line. So you notice that it is on number 7. So this is 0, 1, 2, 3, 4, 5, 6, 7. And then you write your answer as 7. So the actual reading now will be equal to main scale reading, which we found to be 25 millimeters, plus vernier scale reading, which we found to be 7. The vernier scale reading should be multiplied with the least count, which we found to be 0.1 millimeters. And then we have to subtract the error, which is 0.3 millimeters, which we found. And you find your answer as, we can find our answer as 25.4 millimeters or 2.54 centimeters. So this is how actually we take into account the error on a vernier calipers. So at times, these errors cannot only be after the 0 error. So at times the error can be before the 0 error. So we'll take another question where we are going to take an example of such an instance. So the jaws of a vernier calipers are in contact. Calculate the 0 error of this vernier calipers. So these are in contact. You notice that if there was no error, the 0 on the main scale is supposed to be in the same line with the 0 on the vernier scale. But however, this one is this side. Okay, and they have told us that the main scale division is equal to 1 millimeter, and 10 vernier scale divisions is equal to 9 main scale divisions. And so what we need to get is, first of all, is the least count. We know that the least count is found by getting, first of all, the main scale division minus vernier scale division. We found that it was 1. The main scale division is 1 millimeter. Each division on the main scale is 1 millimeter, minus these out of 10 divisions, there are only 9 divisions on the main scale. So what this means is that it is 9 over 10, and therefore you get 0.1 millimeters. And so if you look, now we get the main scale reading. The main scale reading, you notice that it is actually 1, because it has gone this side by 1. So if you check on this one has gone at least 1. Because of this one, it's -1. So it gives us a -1. And then the vernier scale reading, you check on the vernier scale reading where they are coinciding. You notice that they are coinciding when they're in the same line, only 4. And you take vernier scale reading as 4. And so therefore the zero error would be main scale reading plus vernier scale reading multiplied by the least count, which is equal to, we found the main scale reading as -1 plus 4 multiplied by the least count, which is 0.1. And this gives us -0.6 millimeters as the zero error on this Vernier calipers. So the Vernier calipers, question 4, the Vernier calipers in question 3 was used to measure the external diameter of a bottle, calculate the reading on the Vernier calipers. So this same Vernier calipers, which had an error of -0.6 millimeters, was used to measure the diameter of a bottle. So here we take into account the error which is there. And therefore, this is now the problem. So we know that if you are to get the reading on the main scale reading, you check on the 0 mark. This is 21, 22, 23, 24 millimeters. And therefore, our answer would be main scale reading is equal to 24 millimeters. What about the Vernier scale reading? Where are they in the same line? You notice that this is 5, 6, 7, 8. So this one is the one. So it is 8. Therefore, the reading will be main scale reading plus Vernier scale reading multiplied by the least count minus the error. And so we found the main scale reading to be 24 millimeters plus the Vernier scale reading was 8, which is multiplied by 0.1 millimeters, which is the least count, minus the error. So there's minus, again minus, you remember we found minus 0.6 as an error, and then this one becomes plus, which will give us 25.4 millimeters or 2.54 centimeters. The other question, calculate the least count on the Vernier calipers below. So we have this Vernier calipers. Fortunately, these are coinciding. There's a 0 here, it's the same line with another 0 here. So they're asking us to find the least count. And you remember, our least count is found by looking at how many Vernier scale divisions are there on the main scale division. Here they have told us 5, if you check here, these 5 divisions, they are equal to, on top there, 1, 2, 3, 4. They are equal to 4 divisions. So 5 divisions on the Vernier scale is equal to 4 divisions on the main scale. And therefore you can get the fraction of this, which will be 4 divided by 5. So 1 main scale division is equal to 1 millimeter, which is given here. Vernier scale division, it will be 4/5, which is equal to 0.80 millimeters. And therefore, the least count would be main scale division, which is 1, minus Vernier scale division, which is equal to 4/5. And this gives us 0.80 millimeters. So this is a lesson where we have actually looked at how we can take readings on the Vernier calipers. Please subscribe to my YouTube as I'll bring more of O-level questions and O-level lessons so that you can be able to write your O-levels and be able to pass them. Subscribe to my YouTube. I thank you.